Welcome to ChemTube channel. I'm Jaegu Wong. Today we are going to discuss the Penang Trial Paper 2020. Let's start. Essay question 7. A hydrocarbon W contains 14.29% of hydrogen by mass. 10.5 grams of hydrocarbon W occupies a volume of 6 cubic decimeter of room condition. So you are given relative atomic mass for hydrogen and carbon. A mole of gas occupies a volume of 24 cubic decimeter at room temperature. So determines the empirical formula of the molecular formula of the hydrocarbons W. So 6 marks. So here the first thing you need to know is the hydrocarbons. So hydrocarbons refer to a compound that contains the hydrogen and the carbon. So in order to solve this question, normally I will encourage you to build a table like this. So first thing, elements, you have to put in the carbon and the hydrogen because they are hydrocarbons. So first thing is the mass. You need to find out the mass first. So the mass, you are given the percentage. So for the hydrogen is 14.9%. So in this case, you just assume the mass total out is 100%. Hydrogen is 14.29%, so we assume it is 14.29 gram. So here you have to put in gram. So in other words, the carbon is 100% minus 14.29. So you will get 85.71 gram. So this is the mass for the carbon and the hydrogen. The second thing is you need to find out the number of mole. So number of mole, we use the mass over the molar mass. So 85.71 divided by molar mass for carbon is 12. So use your calculator, you'll get 7.143. Then after that, for the hydrogen, same case, mass is 14.29 divided by the molar mass is 1. So you will get 14.29. After you get the number of mole, we have to find the mole ratio. So here we compare the both mole with the smaller number of mole. Here 7.143 for the carbon and hydrogen is 14.29. So carbon is mole for the carbon is smaller. So we divide both number of mole with 7.143. 43 divided by 7.143. You get whole number 1. So here 7.29 over 14.29 divided by 7.143. So roughly you get the number is 2. So here we can get the empirical formula. We copy it down. C1H2. So this is the empirical formula for the hydrocarbons W. Next we need to find out the molecular formula of the hydrocarbons given. So here, how do we start? We can use the number of mole formula to find out the molecular formula. So we know that mass over molar mass is the number of mole, and then volume over the molar volume is also number of mole. So given here, the mass of the hydrocarbons W is 10.5 gram. So we can replace in here in the mass. Molar mass we can find out afterwards. Then after that, volume given is 6 cubic decimeter, and then molar volume given is 24. So we just replace in every information given here. So it's 10.5 over the molar mass. So we need to find the molar mass of W equals to volume is 6 over molar volume is 24. So in this case, we use the cross multiply. So meaning that 6 times molar mass. So molar mass of W equals to 10.5 times 24, then divide by 6. So you will get the value is 42 gram per mole. Okay. So this is the molar mass of the hydrocarbons W. So it's 42. So we can replace in the empirical formula there. Okay. So molar mass of the W is empirical formula just now is CH2. So we replace in to the formula here. So times N. Okay. So C is 12, H is 1 times 2, so 2. So we replace in molar mass is 42, so equals to 14N. So we find out the N is 3. Okay. After we get the N is 3, so since the empirical formula is CH2, so we times the N is 3. So meaning that so the molecular formula for the W is, so let's say N is 3, so meaning that it becomes C3H6. So this is the molecular formula for the hydrocarbons W. Okay. Now, okay, number 2. State the name of the homologous series for W and explain your answer. So first thing is, what is the meaning of homologous series? So homologous series is a family of the hydrocarbons with similar chemical properties, same general formula and functional group. Okay, for example, in the SPM level, we have alkane, we have alkene, alcohol, carboxylic acid, and ester. These are the 5 homologous series in the SPM syllabus. So here, okay, we found out that just now the molecular formula is C3H6. So based on the information given here, we know that the homologous series is alkene. How do you know that? Because the general formula for the W is CnH2n. Okay, so N start from 2, 3, and so on, meaning that this is the alkene homologous series. Number 3, write a balanced chemical equation for the complete combustion of the hydrocarbons W with oxygen. Okay, so the chemical formula equation for the combustion, complete combustion. Okay, so here, okay, our hydrocarbon W is C3H6. So in the combustion, so it will react with the oxygen. So the products are carbon dioxide and the water. Okay, so once you get the correct reactants and product, you get 1 mark. Okay, another mark is for the balancing. So class, how do we balance the chemical equation here? So we start with the carbon. Okay, so carbon is C3. So here is only 1 carbon, so times 3. Okay. Then hydrogen, it has 6 atoms here. So here 2 only, so times 3. Okay. So finally we check the oxygen. So oxygen, 3 times 2 is 6 oxygen. 3 times 1, so 3. So 6 plus 3, total is 9 oxygen. So 9 oxygen here is the even number. So in this case, we can use a fraction. Okay, for the fraction, how do we get the 9 oxygen? So we can use the 9 over 2. So only the combustion we are allowed to use a fraction in our chemical equation. So in actual fact, if you don't want to use the fraction, okay, we can do like this. The overall equation we times 2. So in other words, you have 2C3H6 plus 9O2 produce 6 carbon dioxide and 6 water. Okay, you can also write like this. Both is correct. Both equation here are correct. Okay. Okay, B. Table 7 shows some information about 3 members of a homologous series. So here again, homologous series, just now we discussed already. So ethene, propene, and butene. So dehydration, okay, preparation and chemical reaction all undergoes hydrogenation. Okay, so you are given this information about the alkene group. Okay. Now, based on the table, state 4 characteristics for the homologous series. So, 4 mark. Okay. Actually, just now I have given you the information about the homologous series already. So here, suggested answer. Number 1, all members contains the same functional group. Okay. So in this case, the alkene, it has carbon-carbon double bond. Number 2, it can be represented by a general formula. For example, in this alkene, it will be CnH2n. Then the difference between one member and the next member is CH2. Okay, CH2. Okay, for example, the first member is C2H4, is the ethene. The next member is propene, so it's C3H6. So the difference of these two members, ethene and the propene, the difference is CH2. Okay, and so on. Number 4, all members can be prepared using the similar methods of preparation. So, like the table just now, all can be prepared using the dehydration. Number 5, all members have the similar chemical properties, okay, as shown in the table. Actually, you can get info from the table just now. Okay, next, ethene can be prepared by ethanol. So describe the preparation of the ethene in the lab. In your description, include the chemical equation in the reaction, suggest a chemical test to test the ethene gas. So for this, I'll show you one video. So have a look here.
Click the play button to see what happens when ethanol vapor is heated strongly over porcelain chips.
So the gas produced is flow into the inverted test tube here. So it will be collected here. So the gas collected, you can test with the bromine water. Bromine water initially is brown color, then finally it is turns to colorless. Okay. We also can test with acidified potassium manganate 7, which is purple color initially, then it will turns to colorless. Okay, so this is how we prepare the ethene in the lab using the dehydration. So how do we present our answer? So preparation. So ethene gas can be prepared by dehydration, okay, of our ethanol using the dehydrating agent such as porcelain chips, aluminum oxide, or concentrated sulfuric acid. Okay. So warm the glass wool, which is soaked in the ethanol to form the ethanol vapor. Then the ethanol vapor then pass through the strongly heated porcelain chips just now. Then the ethene gas produced is collected by displacement of water in the test tube. Okay. Then after that, how do we the chemical equation? So it's ethanol, so it produces ethene and release the produce the ethene and the water. Then how do we test it? So we can add the bromine water into the test tube containing the ethene. should be ethene gas, not ethane gas. Ethene gas. Then what is the observation? This is the action you do, and then the observation here, the bromine water decolorize. Okay, so whenever in doing the chemical test, remember you need to include what is the action taken, and then what is the observation. Okay, so normally it's 2 marks. Question 8. Diagram 8.1 shows an example of a favorite food amongst teenagers. So I think you'll also all like this burger and then the ice cream. A1, sodium nitrate is an example of the food additives added to the meat in the burger. Then state the type of food additives which sodium nitrate belongs and its function. So 3 marks. So actually sodium nitrate, whenever you see this kind of additives, you know that it is the preservative. Okay, preservative. Then it reduces the growth of the microorganism. Okay, then what is the side effect of the sodium nitrate on our health? Let's say in a long term, okay, and then consume in a large quantity, the side effect, it may cause the cancer for taking long period of time. So be careful. Okay. Number 2, the ingredients in the ice cream are as below. Ethyl butanoate actually is ester, evaporating milk, sugar, sunset yellow, and lecithin. From the list of the ingredients, state one example of the food additives that act as the stabilizer. Okay, then stabilizer. Okay, what is the meaning of or what is the function of the stabilizer? Is actually is used to prevent the oil-water emulsion from separating out in the products. So meaning that what is the if it is not added to the ice cream? So the stabilizer here actually is the lecithin. Lecithin. So what is the effect if not added into the ice cream? The ice cream may separate to form 2 layers of water and the protein, because the stabilizer is used to make them to mix together well. So if not, it will separate out. Okay, B. 2 students met a daughter with the symptoms shown in the table 8. Table 8. Eileen, hard to sleep, nervous. Okay, maybe you too nervous in study, preparing your SPM exam. Then Zakwan, prolonged chronic cough with bloody mucus. Okay, then state the type of the example of the medicine that should be taken by Eileen and Zakwan to relieve their sickness. And then Zakwan is advised to finish up the medicine accordingly to the prescription. Explain why. So 6 marks. So first thing you have to mention both students, what is the medicine type and example for the medicine that should be taken. So here, Eileen, it should take the psychotherapeutic medicine. Okay, for example, barbiturate or tranquilizer. Any one of these can be accepted. How about Zakwan? Zakwan has a bad cough. Okay, it should take the antibiotic. Here, example can be streptomycin or penicillin. Okay. And next question is why it should be. What is the why it advised to finish up the medicine for Zakwan? Okay, to ensure all the bacteria are killed. Okay, and then so that it won't get sick again or prevent the bacteria immune to the antibiotic. Okay, so this question actually is very popular in the SPM level. C. Okay, stubborn stand is made of oily or greasy material. If only water is used, not all greasy stand can be removed. Therefore, soap is needed to get rid of the stand. The diagram 8.2 shows the part of cleansing action of the soap particles in the grease. Okay, so this is a part A, and this is the part. This is cloth. This is a grease. Actually, part A is the head. The head. This is the tail. The part A, actually we call it hydrophilic, soluble in water. The tail is hydrophobic. It's soluble in grease. Okay. So explain how the cleansing action of the soap can remove a greasy stains. So 9 marks. So before that, I show you one video on the cleansing action of the soap.
When soap dissolves in water, they form sodium ions, positive sodium and anions. The hydrophobic part of the anion dissolves in grease. The hydrophilic part dissolves in water. Grease is loosened and lifted off the surface. In the washing machine, heat and the agitation of water aids in this process. The charged ends of the anions surround the grease. The grease is lifted off by the water and suspended. The grease is dispersed into smaller drops. Again, the heat and the agitation of water aid in this process. The rinsing away of dirty water removes the grease droplets. The grease is removed from the towel.
So this is how the soap can remove the grease stains on the cloth. Okay, so how the cleansing action. Number 1, soap ion consists of hydrophilic head and a hydrophobic tail. Point number 2, hydrophilic part soluble in water, and then hydrophobic part soluble in grease or oil. Okay, so these two have to remember it, memorize it. Next, soap reduce the surface tension of water so that to make the cloth can be wetted easily. Then soap emulsify grease into the small droplets. Then foam producer helps to float the emulsion. Then agitation during the scrubbing and pull the grease free from the cloth. And then repulsion force between the negative charges on the cloth surface prevent the grease from redepositing onto the cloth again. Okay, so these are the points that you can write in the cleansing action of the. Okay, question 9. Table 9 shows the heat of neutralization for 2 sets of experiments using different monoprotic acids at X and Y reacting with potassium hydroxide solution. Okay, so you are given 2 types of monoprotic acid. So heat of neutralization is different. Okay, so this one higher, this one lower. So before that, I show you what is the meaning of monoprotic acid and includes diprotic acid here.
Look at the number of hydrogen ions produced. Hydrochloric acid releases 1 hydrogen ion. An acid that can give up 1 hydrogen ion per molecule of acid is called a monoprotic acid. Hydrochloric acid is an example of a monoprotic acid. Whereas sulfuric acid releases 2 hydrogen ions, an acid that can give up 2 hydrogen ions per molecule of acid is called a diprotic acid. Sulfuric acid is an example of a diprotic acid.
Okay, so here you are given 2. So here, next look into the question. Based on the table 9, name 1 example of X and Y. So here, okay, we can see that monoprotic acid X, it produces a higher heat of neutralization. Y produce a less heat of neutralization. In other words, X is a strong acid, strong monoprotic acid. Y is a weak monoprotic acid. So here we can suggest that acid S is a hydrochloric acid or nitric acid. Both are strong monoprotic acid. You have to here, if you write sulfuric acid is wrong, because sulfuric acid is a diprotic acid. Acid Y is a weak monoprotic acid, for example, ethanoic acid or propanoic acid. Okay. Now explain why there is a difference between the value of heat of neutralization. So 4 marks. Okay. So X is a strong acid that ionizes completely in water. Okay, this is the first thing you have to know for the strong acid. To produce high concentration of hydrogen ions. Okay, so whenever you want to define or explain the strong acid, remember these 2 points. Now Y is a weak acid ionized partially in water, produce low concentration of hydrogen ion. So this is for weak acid. So some heat during the neutralization is absorbed by the acid Y molecules to ionize the completely to form the hydrogen ions. So the heat of neutralization for acid X is higher than acid Y when react with potassium hydroxide. Now calculate the change in temperature for the mixture in the set 1. So here given to you monoprotic acid 50 cubic centimeter. Okay, given to you the heat of neutralization is 57. Okay, so we use the formula Q equals to mc theta. So the m given is 100 is 50 plus 50, so 100. Heat capacity is, specific heat capacity is 4.2. Then T1 is the temperature change. So we put this first. Later on we have to come back here to find the T1. So number of mole, we use MV over 1000 for both. Okay, acid or alkali are the same. So M is 2.0, V is 50 over 1000. So you can choose the acid or alkali to calculate the number of mole. Both are the same answer. You get 0.1 mole. Okay. After that, we use the delta H equals to Q, the Q here over the number of mole. So Q equals to mole times the delta H. So here we can find so number of mole for the is 0.1 times the mole delta H given is 57 kilojoule. So you get 5.7 kilojoule. So we have to change to joule first, meaning that time 1000, so it's 5700 joule. Okay, so once you get the Q, so we can replace in the heat release formula here. So meaning that 100 times 4.2 times T1 equals to the delta H, the Q, sorry, is 5700. Okay, so T1 is 5700 divided by 4.2. So use your calculator. You will get the value is 13.57 degrees Celsius, or you can round to 13.6 degrees Celsius. Okay, so this is how we do the calculation for the heat of reaction. Now see, by either using either acid X or Y, describe the experiment to determine the heat of neutralization. In your description, include the procedure, thermochemical equation involved, and then the energy level diagrams. Okay, so before that, I show you the video how to determine the heat of neutralization. So I hope that you remember the steps.
Watch the video and answer the following questions. 50 cubic centimeters of 2 mole per cubic decimeter sodium hydroxide solution is poured into a polystyrene cup. The initial temperature of the solution is measured with a thermometer. Record the reading in the table provided. 50 cubic centimeters of 2 mole per cubic decimeters hydrochloric acid is poured into a polystyrene cup. The initial temperature of the solution is measured with a thermometer. Record the reading. Calculate the average temperature of both solutions. Hydrochloric acid is poured into a polystyrene cup containing sodium hydroxide solution. The mixture is stirred and the final temperature of the mixture is measured with a thermometer. Record the reading in the table provided. What is the difference in temperature during the reaction? Key in your answer in the table. Now, with the data we have, we can calculate the heat released from the reaction.
So the procedure: measure 50 cubic centimeter of 2 mole per cubic decimeter potassium hydroxide solution and pour into the plastic cup. So just now the video used the sodium hydroxide. Here we use the potassium hydroxide in the question. Then record the initial temperature. Measure 50 cubic centimeter of 2 mole per cubic decimeter hydrochloric acid and pour into another plastic cup. Record the initial temperature. Then add the hydrochloric acid quickly and carefully into the potassium hydroxide solution. Then stir the mixture. Then record the highest temperature, not the final temperature, highest temperature. Okay. Then for the thermochemical equation, here we have hydrochloric acid with the potassium hydroxide, then produce the potassium chloride and the water. So the delta H is 57 kilojoule per mole. So it's the negative sign, shows it is an exothermic reaction. So the thermochemical equation, just addition of the delta H at the back. The remaining are the same as the chemical equation. The energy level diagrams here. So here this is a exothermic reaction. So here I give you a general how we draw the energy level diagrams for exothermic reaction. So first you have to draw the energy axis. So remember to label the energy. Okay, so the levels for the reactants is higher compared to products. So products, so decrease the products. So here the reactants we just copy in HCl with KOH. Product is KCl and water. Then finally we have to put in the delta H is 57 kilojoule per mole. Okay, so in beside this you also can use the ionic equation. So you also can use hydrogen with hydroxide ions, produce the water. You also can use this to replace in the chemical equation. Question 10. Table 10.1 shows the properties of the arrangement of atoms in two types of materials, P and Q. So materials, P is an alloy, Q is a pure metal. Okay, so let's have a look here. P is soft and less strong, easily rust. Q is hard and strong, not easily rust. So we can see the arrangement. So here is the iron atom. Okay, this is for the pure metals. Then this is addition of carbon atoms. So directly we know this is the iron, pure metals. This is iron with the carbon, so it's the steel. So let's look into the formation of the alloy of steel.
Pure solid iron is melted. Carbon is added and mixed with the liquid iron. The alloy form is steel.
Okay, so this is how to form the steel alloy. Yeah? Okay, so material Q is more suitable than the material P to make the railway tracks. Explain in terms of arrangement of the atoms. Explain why the material Q is more suitable to make the track. So 4 marks. So number 1, you can mention substance Q consists of 2 types of atoms of different size. Different size. Okay. Next, presence of the fluorine atoms disrupt the orderly arrangement of the pure metal. Or disrupt the orderly arrangement. Okay. Next, the layers of the atoms difficult to slide easily when the force is applied. Okay, then it makes it stronger and harder. So this is the explanation for the alloy. So whenever you use the you want to explain alloy, these are the points that you need to mention. So please pay attention here. So by using one example of the pure metal and its alloy, describe how the experiment shows the alloy is able to withstand the corrosion compared to pure metals. Your answer should include the procedure, result, and conclusion. Okay, so 10 marks. So here I use the example of this one. Okay, so the iron nails and the stainless steel nail. So they both are put into the agar-agar or jelly mixed with the potassium hexacyanoferrate 3 solution. So actually this potassium hexacyanoferrate 3 is used to detect the presence of iron 2 ions. So if the nail is rust, so it will produce iron 2, Fe2+. If not rust, it won't produce the iron 2 ions. Then it will show the dark blue coloration or dark blue spots if the presence of iron 2 ions. So by using this experiment, we can show the alloy is able to withstand the corrosion compared to the pure iron nails. So procedure: clean the iron nails and the stainless steel nail with the sandpaper. Number 2, put both nails into 2 test tubes and label with A and B. So if you do the experiment simultaneously, so normally I suggest you to label it. So later on, you can easily mention it is test tube A or B. Then add the jelly mixed with potassium hexacyanoferrate 3 solution in both test tubes until it covers the nails. Leave both test tubes for 3 days. Then record the observation. These are the procedure. So by using one example, the result. So test tube A, you see a lot of blue spots is formed. Okay. Then B is a little blue spot is formed, or no blue spot is formed. You also can mention that because stainless steel. Okay, or no blue spots. Okay. So conclusion we can make is iron nail rust quickly and steel nail rust slowly, or do not rust. You also can write do not rust. Does not rust. Okay. Next, B, 10.2 table 10.2 shows the 3 manufactured substances in industry XYZ and their uses. So X is to make the glass or cookware or boiling tubes. Okay, so you know. Okay, later on. Okay, B, to make the helmets and the water storage tank. Okay, this is the helmet. Then Z, to make the internal wall of the furnace. So this is the internal wall. Okay, so this is under manufactured substances. Okay, So determines the name of the substances X, Y, and Z. So X is actually a borosilicate gas. Borosilicate glass. It can withstand high temperature and chemical reaction, so it can use to make the glass cookware and then the boiling tubes. Y is a fiberglass. It's a very light and strong, so it can make the helmet and the water storage tank. Then Z is the ceramic because it can withstand a very high temperature, so it can use to make the internal wall of the furnace. Okay, so thank you very much